Hey bro. Hey bro. I made nimbu pani, bro. It was delicious, bro.
Oh damn.
Yeah, damn.
Teach me how to make it, bro. Wait, let me put my earphones on.
Okay, do one thing. Take a container, bro. Now, put 1 spoon of salt, bro.
1 spoon of salt.
Put 1 spoon of sugar, bro.
1 spoon of sugar.
Squeeze in a lemon, bro.
Squeeze a lemon.
Now, put 1 bottle of soda, bro.
Oh, 1 bottle of soda. Okay.
Oh yeah.
Bro, this doesn't even look like nimbu pani, bro.
Where? You are dumb, bro. Bye. I'm sure you understood what was the problem in this case, yeah? The measurements on both of the sides were not the same. So the same problem is something that we face in chemistry, because in chemistry almost everything that we deal with is in a mixture or a solution, yeah? And if we don't know what's the proper concentration of the solution, if we do not know what's the proper composition of the solution, this might end up happening. Since no one of us wants that explosion to happen in the laboratory, as chemists, what we do is we define certain standards. How do we write the recipes of these solutions, essentially, is the topic for today's class. So today's class is very important because it finds a lot of applications in the practical world, of course, and also in all the other chapters of physical chemistry, we'll be using these ideas. So pay a lot of attention for today's class. Let's try to understand how to write the recipes of these concentrations. Let's get back to the board. Hello everyone, welcome to Catalysis by Vedantu. If I'm audible and visible, please write yo in the chat box, you know the drill. And I hope you enjoyed the intro part, yeah? Try to do something very weird for you guys so that you understand the significance of what this class is about. And as I told you, we need to understand how to write the recipes. Now, we can't just go on saying that I have made a solution which has 1 spoon of salt and 1 liter of water. That's just too much, yeah? So we as scientists need to learn new jargon, yeah? Before we learn new jargon, let me teach you a little bit of English, which I always do, yeah? So you know the meaning of the word jargon, people? Yeah, jargon is something that it's a word that I use quite a lot. It's essentially a word for, vocabulary of a specific profession. So people like us will use words which only chemists can understand, yeah? So that is chemistry jargon, alright? So today we are going to learn some chemistry jargon, alright? So, ye dekho dosto, today these are the things that we are going to learn. A lot of people are scared of these, I don't know why, but what I will do is I will try to make them as easy as possible for all of you. So this is what's today's analysis, strength of the solution. And technically speaking, it is the amount of solute dissolved per unit of solution or solvent, and that is called the strength of solution. There are multiple ways of writing the strengths of solutions. Let's just read their names first of all. Mole fraction, fraction of moles, something like that, yeah? Mass percentage, percent in terms of mass. Mass by volume percent, sounds a little tricky, we'll understand that. Volume by volume percent, once again simple, percentage of volumes. Grams per liter, how hard is it? Parts per million, molarity, etc. But before we understand the strengths of the solutions, we need to understand something. Can anyone tell me what is a solution? Can anyone tell me what is a solution? फटाफट से chat box में मुझे answer दो. What is a solution? Okay. Gaurav is saying, sir, Menti quiz le lo. Gaurav, welcome to Catalysis. I do not take Menti quizzes, my friend, because they are just a pure waste of time. Let 6th class students do Menti quizzes. We are smart enough to understand things without Menti quizzes as well. So I hope that is fine. चलो जी, तो solution को कैसे define करेंगे? A lot of you would be saying, sir, solution is simply solvent plus solute. Yeah. People will simply say solvent plus solute, है ना जी? देखो, that's not necessarily true. If you think about it, You could have a solution of n number of components. Yeah, you could have infinite components inside a solution. Even the alloys that you have are essentially solutions. So solution is basically just a homogeneous mixture. Solution is just a fancy word for a homogeneous mixture where there are multiple components. It could be solid, solid, liquid, solid, gas, solid, etc., etc. But if we think about a binary solution, okay, solution could be anything, but let's focus only on binary solutions for now, because those are what matter for us in today's analysis. Okay, so binary solutions bole to, binary solution implies you have only two components. Yes, yeah, this is what binary solutions are, only two components. Now in these two components, you will call one of them the solute and the other one will be called the solvent. Now my dear friends, how do you choose which one is which? Can you tell me which one is the solute, which one is the solvent, or simply tell me what is the criteria for choosing a solvent? फटाफट से बताना. And for those of you who are wondering, sir, what about the homework for the previous class? What about the Hall of Fame? We'll discuss those ideas later. ठीक है? In the middle of this class, while we are solving questions, we'll do the question that we've left in the previous class as well. So don't worry. Okay? Got it? So what do you think? What would be the solute and solvent? And people who are joining us late, welcome to Catalysis by Vedantu. I hope you watch this live session from the beginning, because we've done something really fun in the beginning of the session. So please make sure you watch that. So Arjun is saying that quantity, Dark Knight is saying greater concentration will be solvent, higher amount, etc., etc. Solute is in less amount. ये वो. Okay, so essentially most of you are suggesting that solvent is in high amount, yeah, and your solute is in less amount, isn't it? And I am pretty sure a lot of people have taught you this, है ना? हो सकता है आपको किसी ने सिखाया भी हो that this is how you choose the solute and solvent. My dear friends, a myth buster for all of you, this is wrong. Absolutely WRONG wrong. Okay, please mark my words, this is according to definition given by the IUPAC, International Union of Pure and Applied Chemistry. Okay, solvent is chosen completely out of convenience. It is your choice. Okay, it is your choice. In a solution which has multiple components, you can choose any one of those components as the solvent. Do you understand? कोई भी मिक्सचर में जो एक चीज है उसको उठा के आप बोलो solvent. It is based out of convenience. That is all. Okay, it is based out of convenience. Even if I dissolve like a lot of salt in water, I will still call water the solvent because it just makes sense for calculations. Okay, so this is generally true, not always true. Okay, this thing that I've struck out, right, this over here is generally true. Again in bracket, not always. Please make sure you note this down. Please clear this misconception of yours. Solvent is chosen completely out of convenience. This is according to the definition of the solution by IUPAC. You can search for it online on Wikipedia in case you want to do that after today's class. Solvent is chosen completely out of convenience. It could be the minor component of the solution. It's just one of the components of the solution. You just call it solvent, everything else is a solute. Okay, so being a greater implies solvent, definitely incorrect. Got it? Solvent हमेशा ज़्यादा नहीं होता. Solvent सिर्फ और सिर्फ आपकी सहूलियत के लिए आप चुन सकते हो किसी भी component को. ठीक है? Solvent is chosen merely out of convenience. Greater amount being solvent is just a misconception. Fine. Please remember this idea. Read the definition of the solution after this class is over on Wikipedia as well. Chalo ji. So now you will choose one of them as the solvent, and in most cases it will be the one that has higher amount. Okay. तो अब discuss करते हैं what are these different strengths of solutions. How can we define these strengths of solutions? The first one is very simple, that is mole fraction. Yeah. Let's read what a mole fraction means. Look at this. Mole fraction is defined as the moles of solute present in 1 mole of the solution. Okay. Mole fraction is moles of solute present in 1 mole of the solution. Make sense? It's just a fraction. Okay. काफी simple सी बात है यार. If let's say I have a component x, okay, how will I write mole fraction of x? Mole fraction of x is equal to moles of x, that is n of x, इस तरह से लिखेंगे, upon total moles in the solution. Total moles in what? The solution. We are not talking about the solvent over here. Solution implies solute plus solvent. Okay, both of these things added together give you the solution. So please make sure you remember that we define mole fraction in terms of the entire solution. Okay, if I have this entire bottle, okay, in this entire bottle, what is the fraction of molecules of or moles of some salt, let's say. Okay, so mole fraction is always defined in terms of the entire solution, not just the solvent. Now this is very simple. This is a very simple idea. Let's just try to do a question and then I'll tell you more things about it. ये देखो, let's do this. Very simple example over here. Yeah, 46 grams of ethanol is mixed with 36 grams of water. Calculate the mole fraction of the solute. Okay, and over here, assume H2O to be the solvent. Okay, over here the assumption is that H2O is the solvent. Valid assumption over here. So this is the question in front of you. 46 grams of ethanol is mixed with 36 grams of water. Calculate the mole fraction of the solute. So let's just solve this quickly. For ethanol, my dear friends, what is the number of moles of ethanol? Given weight upon molecular weight, given weight, I'll write GW upon molar weight, MW. This is equal to how much? 46 divided by, what's the weight of ethanol? Ethanol's formula is C2H5OH. Alright, so can you tell me what's the molecular weight of ethanol? Quickly, can you tell me what's the molecular weight of ethanol? Abhinav is saying, sir, but why moles of solute plus moles of solvent is moles of solution? Abhinav, why is 1 plus 2 equal to 3? Because 3 has 1 and 2. What is a solution? A solution has just solvent and solute. Add them together, you will get the solution, bro. Like, what are you asking, my friend? अरे भैया थोड़ा दिमाग तो लगा लो, प्लीज. ठीक है. सो यस, 46 आ जाएगा इसका वेट कैलकुलेट करोगे तो 24 प्लस 16 40 और 6 46. सो moles of ethanol are equal to 1. Yeah. Then if you calculate the moles of water, moles of water are equal to 36 divided by 18, that is equal to 2. Fine. So my dear friends, can you calculate the mole fraction of ethanol? This weird symbol that I've made, this weird symbol is known as the symbol chi, C-H-I, chi. Alright, it's a Greek letter as we use them all the time in chemistry. So chi of ethanol will be the moles of ethanol, okay, moles of ethanol upon total number of moles. Total number of moles would be moles of ethanol plus moles of water. That is equal to how much? 1 divided by 1 plus 2, that is equal to 3. As simple as that. Yeah. Similarly, can I write what is the mole fraction for water? What is the mole fraction for water? Mole fraction for water is also very simple, 2 by 3. And do you realize that mole fraction of water plus mole fraction of ethanol over here is equal to 1. 2 by 3 plus 1 by 3 is equal to 1. And isn't that obvious? That's the meaning of the word fraction, isn't it? That's the meaning of the word fraction. So let's just build a hypothetical solution in our mind. Let's build a hypothetical solution in our mind which has 3 components, A, B and C. There's a solution with 3 components, A, B and C. Number of moles of A is Na. Number of moles of B is Nb. And number of moles of C is Nc. As simple as that. Now Can we write the mole fractions in each of these cases? We sure can. And I can write chi of A is equal to Na upon Na plus Nb plus Nc. As simple as that. Chi of B can be written as Nb upon Na plus Nb plus Nc, and chi of C can be written as Nc by Na plus Nb plus Nc. That is absolutely simple, isn't it? Number of moles upon total number of moles, as can't get any more simple than that. Yeah. Now, if I add chi A plus chi B plus chi C, what am I getting? I am getting Na plus Nb plus Nc divided by Na plus Nb plus Nc. This is equal to 1. Fine. So if you know a little bit of mathematical notation, the sum of all mole fractions is always equal to 1 inside a solution. Makes sense, right? This is the symbol for summation. This is the symbol for mole fraction. I accidentally wrote moles over there. This is better. Chi of I. Yeah. You add all the mole fractions, they will be equal to 1. As simple as that. So mole fraction, the easiest way of denoting things over here, and this idea can be used for any type of solution: solid, liquid, gas, solid solution. Whatever solution you have, mole fraction works all the time. Very versatile way of writing the concentration of the solution. Cool, fine. Now people, let's look at the next thing. Let's look at the next type of strength of solution, and that is mass percent, right? Let's look at mass percent. Now, what does mass percent mean? Mass percent essentially means percentage of something in the entire substance. Yeah, that's exactly what it is. Let's read the definition as well, because definition is important. Definition कहाँ चली गई भैया? हे भगवान, जनता हमारी definition गायब हो गई जरा. चलो मैं लिख देता हूँ यार. I'll write the definition over here. तो स्लाइड गायब होगी डेफिनेशन की. So mass percent is weight, let's say in grams, of solute in 100 gram of solution. That's what it means. 100 grams of solution. So let me give you an example. Okay, example करते हैं. Let's just think about this example. Okay, let us take क्या किया जाए? Let us take 0.1 mole of NaOH in let's say 36 grams of water. ठीक है जी, this is what I am giving you. I have taken a solution where I have 0.1 mole of NaOH in 36 grams of water. What is the percentage weight by weight? What is this percentage weight by weight? ये जो लिखा है मैंने यहाँ पे. Percentage W by W is just simply known as mass percent, or percentage W by W, or weight of solute in 100 grams of solution. So for this particular solution, we have to calculate what is the percentage W by W. ठीक है? So what do you need? You need weight in grams of solute in 100 grams of solution. Okay? So we need to understand and manipulate this statement that we have to get to the final answer. Let's do it step by step. The steps are very important. Pay attention. My dear friends, 0.1 mole of NaOH. Can you tell me what's the weight of this thing? Can you tell me what's the weight for this thing? Yeah. And people who are wondering, who are new to the channel, welcome to Catalysis. We are doing this chapter of mole concept. We are understanding the concentrations of solutions. Yes, this is for 11th class students. And in case you joined the class late, please make sure you watch it from the beginning. बताओ जी, 0.1 mole of NaOH, what is the weight of NaOH. Assume that NaOH doesn't just disintegrate into water. Assume this, it remains as NaOH as in water. So what's the weight of NaOH? 23 plus 16 plus 1. This is equal to how much? 40. Yeah, if my calculation is correct. Okay. So this is 40 grams per mole. So my dear friends, can I say that this is 4 grams? Can I say 0.1 mole of NaOH is 4 grams? Because 1 mole is 40 grams, so 0.1 mole is 4 grams, isn't it? Okay. So what I have is 4 gram NaOH in 36 grams of water. So my dear friends, assuming that when you combine them together, the total weight of the solution doesn't change. We are assuming that total weight of solution will not change, obviously, because law of conservation of mass. There's no assumption in that. That's pretty logical. Yeah. So can I write total weight of this solution? What is the total weight of this solution? Total weight of this solution is 40 grams. Is that right? Can I say the total weight of the solution is 40 grams? Because I have to add solute and solvent to get to the solution. Understand? Solution aa gaya. So total weight of the solution is 40 grams. So I have 4 gram NaOH in 40 grams of solution. Isn't it? Yeah. Can I write it as 1 gram NaOH in 40 by 4, that is equal to 10 gram of solution? So can I say I have 10 gram NaOH in 100 gram of solution? So my dear friends, this solution that I have made, its percentage weight by weight is equal to 10. 10% of the solution in terms of weight is NaOH. Makes sense? Yeah, makes sense, isn't it? Fine, do you understand? If I have like, let's say the human body, yeah, let's say we have human body, we say 80% of the human body is water. What does that mean? That 80% of my weight is made up by water, because water is there in the blood, in the cells, in it, etc., etc. Yeah. So composition by weight, this is what it implies, that out of the entire solution, 10% is the solute. ठीक है जी? So 90% will be water. Got it? Very simple. I usually saying just simple mathematics. I agree with you 100%. This is what it is. Yeah, percentage weight by weight. 10. Khatam. Nothing complicated about it. Okay. Now similarly, we were doing weight in grams of solute in 100 grams of solution. We can define this in terms of volume as well. Okay. So now we have mass by volume percent or weight by volume percent. For chemists, weight and mass is exactly the same thing. Yeah. So percentage W by V. What does this mean? Let's read it. And my dear friends, please make sure you are writing things down, make your own notes. I will not be providing the PDFs of these sessions, because giving PDFs is as good as spoon feeding. If I start giving you PDFs, I'd rather solve all of your examinations and give the JEE and NEET for you. But that is something that's not possible. So what you have to do is put your own effort. Please make your own notes, because later on you'll be able to revise much better from your own notes. ठीक है, वो बहुत ज़रूरी है. So I am not giving PDF over here because I am that strict teacher who's wishing well for you, and because of you only, because I want you guys to get good ranks eventually in examinations. Not sharing the PDF with you. I hope you understand. Not here to shout and get views. Cool. Chalo. So mass by volume percent. It represents the mass of solute in grams present in 100 milliliters of the solution. This is talking about the overall volume of the solution. Okay? So mass of solute in grams present in 100 milliliters of solution. Okay? 100 milliliters of solution. So imagine you have a bottle of juice, and that bottle of juice is 200 milliliters. So on the back you see ingredients, etc. It might be written that the concentration of mango pulp inside this juice is 3% weight by volume, which means that in the 100 milliliter bottle you have 3 grams of mango pulp. ठीक है, that's a very relatable example. So it just says represents the mass of solute in grams present in 100 milliliters of solution. Okay, percentage W by V. So mass of solute in grams divided by volume of solution in milliliters into 100 is something that you can work out as the formula. It's a very simple idea. When we see some more questions on this, we'll be able to understand it better. But for now, please make sure you write these volume conversions down. Okay. 1 milliliter is equal to 1 cubic centimeter. It is also written as 1 cc. Cc is just a fancier word of cubic centimeters. Yeah. If you guys like automobiles, do you like to think about riding bikes, or maybe you do ride a bike or drive a car, or maybe you want to do it later in the future? Yeah. So whenever we talk about the engine capacities, we either say that this car has a 1200 cc engine, or we say it has a 1.2 liter engine. Yeah. So 1200 cubic centimeters is as good as 1.2 liters. So that is just a way in which I remember things. Yeah. Just by thinking about automobiles. But all the conversion factors are given over here. Okay. So Nemophilist is asking, sir, can it be kg and liters? Acha. So let's try to understand. Let's take an example. It's an interesting question. Let us say there is 20 gram solute in 100 ml of solution. Can I say this is 200 gram solute in 1000 milliliter of solution? This is as good as 1 liter. So can I say kilograms and liters? No. Okay. Think about it in grams per milliliter and then multiply both sides by 10 to get it into liters, but it's not kg per liter. Okay, that's, if you define kg per liter, that will be a different standard altogether. That will be a different way of measuring the concentration. This, however, is not that. Okay, so it's also represented by percentage weight by volume. This solution that is there can simply be written as 20% weight by volume. Okay. If you have ever noticed the composition of cough syrups, have you ever had cough syrup? Yeah. उसके पीछे अगर देखोगे ना, you will see percentage alcohol is this much. Same idea. ठीक है. Cool. Vishal is asking whiteboard कब आएगा? बहुत जल्दी दोस्त, बहुत जल्दी. Very soon. Cool. Stay till the end of the class. I'll give you more details on that. अभी बताने लग गया तो फिर क्या फायदा? Okay, so this is mass by volume percent. Now the next thing is when you have liquid in liquid solution. So it makes sense to measure both of their volumes. So the next thing that we'll discuss is percentage volume by volume. Okay, percentage volume by volume. Okay, so it represents the volume of solute present in 100 milliliters of solution. Okay, so if I have to give you an example over here, which is already given, चलो ये देखो दिया हुआ है. Cough syrup contains 5% volume by volume alcohol, which means that 5% of this solution by volume is an alcohol. Do you realize these are just English sentences that we are writing? This is not chemistry that we are learning today. We are just learning English. Yeah. So 5% volume by volume alcohol implies that this solution contains just 5% of alcohol by volume, which means that you have 5 milliliters of alcohol present in 100 milliliters of solution. My dear friends, do you realize I can also write I have 5 liters of alcohol present in 100 liters of solution? That also makes sense, right? As long as the numerator and denominator are in the same units. क्या फर्क पड़ता है कैसे ली percentage? How does it matter how you take the percentage? Yeah. So over here, 5% volume by volume solution implies 5 milliliters of alcohol is present in 100 milliliters of the solution. All right, as simple as that. So just notice this idea that's there. Volume of solute will be 5 milliliters, so volume of solvent will be 100 minus 5. Yeah. Again, very simple idea. Nothing complicated about it. Just इसको एक बार लिख लो. When we will solve questions on these ideas, it will become much more simple for us. Today is learning the jargon. The next class, which is going to be on Thursday at 7 p.m., we'll be applying this jargon, right? So all of you who have joined just right now, thank you so much for joining Catalysis. Please make sure you watch this video from the beginning because we've done something really fun in the start. And yeah, let's continue. Volume by volume percent. Then we have grams per liter. So someone was asking, I forgot your name, sorry. Someone was asking, sir, what about kilograms per liter? You can define that as well. Let's define similar things. Grams per liter. Okay. It represents the mass of solute in grams present in 1 liter of solution. Okay. बड़ी घटिया सी चीज़ है. कोई बड़ी बात नहीं है यहाँ पे. Okay, so what is happening? Mass of solute upon volume of solution in liters. Example देखते हैं. Example से ज़्यादा समझ आता है. Examples are something that make a lot more sense. A solution is 0.5 gram per liter of NaCl in water. What does this mean? What does this mean? That the entire solution has 0.5 grams of NaCl in 1 liter of the solution. Okay, so 1 liter of the solution contains both NaCl and water in it, and out of that entire solution 0.5 grams is just salt, NaCl. So mass of solute is 0.5 grams, volume of the entire solution is 1 liter or 1000 cubic centimeters. Okay, so I will give you a question right now. Okay, gram per liter of a solution is equal to 26. Okay, grams per liter for a solution is equal to 26. 6. Express its concentration in percentage weight by volume. This is my question to you. Very simple question. We've just understood both of these terms. Read the question carefully. Once we solve these, things will get fixed in your brain a little better. Grams per liter of a solution is equal to 26, which means that there are 26 grams of solute in 1 liter of a solution. Express this concentration in percentage weight by volume. Did you understand the question? It just wants you to convert one type of concentration expression into the other. Let's try to do it. Very simple idea. Yeah. What will we do over here? This solution is 26 grams of solute in 1 liter of solution. It always makes sense to write things step by step. Right now, if you're learning this chapter for the very first time, or let's say you're in 11th class, to get better at the calculations, please write everything one by one. Later on, when we are smart enough to do the calculations quickly, we won't write everything. But to start with, you have to write everything because your brain will become used to thinking in the same manner. So can I write this is equal to 26 grams of solute in 1000 milliliter of solution? You will be like, sir, ऐसे क्यों कर रहे हो? So that when we do questions, life is simpler. Okay, so 26 grams of solute in 1000 milliliters of solution. Can I write 2.6 gram of solute in 100 milliliters of solution? And my dear friends, do you realize this is the exact definition for percentage weight by volume? Weight of solute present in 100 milliliters of solution is known as percentage W by V, and that's exactly what we've written over here. 2.6 grams of solute in 100 milliliters of solution. As simple as that. Okay, step by step, no problem over here. If you don't write these steps down, you might do silly mistakes like saying, sir, the answer is 260. Sir, the answer is 0.26. Sir, the answer is 226 only. So in order to avoid those errors, it's always better to just write things down one by one. Understood? Cool? Great. So people, before moving on to parts per million, let's just quickly read all the ways of expressing the concentration. Mole fraction, we understand that. Fraction of number of moles. Mass percent, percent by weight. As simple as that. Mass by volume percent, grams of solute in 100 milliliters of solution. Volume by volume percent, volume of solute in 100 milliliters of solution. Or I can say liters of solution in 100 liters, liters of solute in 100 liters of solution. Yeah, essentially, you're just comparing volume with volume and then calculating the percentage. Grams per liter, nothing can be more obvious than this. Yeah, grams per liter, grams of solute in liters of solution. Now comes parts per million, parts per billion, and then we'll get into molarity and molality. Okay? My dear friends, can you tell me what is 1 million? Since everyone is watching YouTube these days, now they've changed it to Indian units of lakhs and 10 lakhs, etc. But can you tell me what is 1 million? 1 million is simply 10 raised to the power 6, isn't it? That's what it is. 10 raised to the power 6. That's what 1 million is. 10 lakh bhi kehte hain अपन इसको. Yeah. So, my dear friends, whenever we are making rice, okay, can I say to make rice, can I write something like this? Put 1 cup of rice and 2 cups of water and cook. Yeah, can I say something like that? Generally, this is what the ratio of rice to water is. 1 cup of rice needs 2 cups of water, generally. Yeah. My dear friends, can I write it as, instead of saying cup and cup, okay, everyone's cup has a different size. The ratio is what matters, right? Can I say 1 part rice needs 2 parts of water? Can I say that? 1 part of rice needs 2 parts of water. Okay, very simple. Now, let us make a very beautiful rice soup. Okay, we have to make a rice soup and we have to feed it to a lot of people, but we have very less rice. So, let me give you the recipe of this rice soup. I will take 1 part of rice in Does this make sense? Ani has already given that idea in the chat box, yeah. Can I say, okay, can I say, according to this statement, that there is 1 part of rice in 10 to the power 6 parts of soup over here? Can I say that, people? There is 1 part of rice in 10 to the power 6 parts of the entire soup. Okay, this soup is useless because hardly anyone is going to get any rice. But still, we have to do some cost cutting because COVID-19. Again, everything that I'm saying is just for example. Please don't start selling this soup to people. If you are successful in selling that soup, then please stop studying. क्यों पढ़ाई कर रहे हो फिर? So 1 part of rice in 10 to the power 6 parts of soup. Yeah. So can you tell me the chemistry version of writing this soup's recipe? I can say that this is 1 parts per million rice. Makes perfect amount of sense, yeah. Okay. Now you will be wondering, sir, why are you talking about this pathetic rice soup? I don't want to drink this rice soup. I rather drink water. You are correct. But whenever we talk about pollutants, have you seen the pollutant concentrations, concentration of carbon dioxide in the gas, percentage of chlorofluorocarbons inside air, percentage of particulate matter in air? In fact, if you read your toothpaste packs, percentage of fluoride in those packs, all of those concentrations, which are very small compared to the entire thing, are referred to as parts per million. Okay. So once again, parts per million represents the parts of solute, which is moles or mass of volume. Okay. ये थोड़ा साइड पे चला गया स्क्रीन के. लेट मी डू दिस. नाउ इट्स इन द स्क्रीन. या सो इट रिप्रेजेंट्स द पार्ट्स ऑफ सोल्यूट, मोल्स, मास ऑफ वॉल्यूम. यू कैन डू 1 kg ऑफ राइस अपॉन 1 million kg of soup. You could do it in terms of moles as well. You could do it in terms of volumes as well. Parts, depending on the context, we'll say parts is grams or cups or moles etc. Parts समझते हो ना, एक भाग ये, बाकी भाग ये. One part this, the rest of the parts are something else. Fine. So it represents the parts of solute present in 10 to the power 6 parts of the entire solution. So let's take an example over here. Yeah, let's take an example over here. This example will clear things out even better. Example is CO2 in atmosphere is 15 parts per million by mass. What does this mean? This means that there is 15 grams CO2 in 10 to the power 6 grams of air. When I say by mass, that's what I mean. Yeah. So just divide by 10 to the power 6 on both sides. You will get that in 1 gram of the atmosphere, if you take 1 gram of air, that air will have 15 into 10 to the power minus 6 grams of carbon dioxide in it. Krishna, yo man, thanks. But parts per million is absolutely simple, isn't it? Nothing complicated about it. See, these concentrations are just English. If you understand English, then you understand these concentrations. If you don't understand these concentrations, then all that means is you are not paying enough attention. To be very frank with you, थोड़ा सा ध्यान दोगे तो कुछ भी नहीं है. ठीक है जी. Now can you guys tell me what would be parts per billion? How can I write ppb? सीधी जड़ी गल है. Very simple idea that billion is equal to 10 raised to the power 9. Yes. Make sense? Parts of solute in 10 to the power 9 parts of solution, isn't it? So that same definition is given over here. It represents the parts of solute, which could be in terms of moles or mass or volume, present in 10 to the power 9 parts of the solution. Very, very simple ideas. And trust me, when we will use these in questions, we'll be able to understand them better. And the questions of this chapter, we'll solve it in the next class. Okay, for this part, the questions that we'll solve will be in the next class, that is on Thursday at 7 p.m. Okay, so आज we'll just learn the definitions, we'll deal with our homework problems, etc. etc. But problems related to the concentrations we'll do on Thursday, so please don't miss that. Okay, ji? So parts per billion represents the parts of solute present in 10 to the power 9 parts of the solution. Rarely is this used, but in case a question arises, we'll try to see what it means. Right? Now, my dear friends, the next thing that we will learn is a very important idea. The next thing that we learn is called molarity, and this is the most important of these all. Okay, molarity is the most important way of writing the recipe of these solutions. Very, very important. Okay, why is this important? See, it represents the moles of solute present in 1 liter of solution. And this is something that makes a lot of sense for laboratories, because most of the solutions inside the laboratories are solid in liquid solutions. Yeah, like you're dissolving salt into liquid, something. So it makes sense to measure the amount of solute that is present in 1 liter of the entire solution. Okay. ठीक है. Cool. So moles of solute divided by volume of solution, moles upon liters. बात खत्म. Once again, we are using the word solution over here. We are using the word solution over here. So people, what's going on? 1.7 molar NaCl aqueous solution. What does this mean? This simply means that there is 1.7 mole of NaCl in 1 liter of this entire solution. Is there anything difficult about molarity? I am pretty sure there isn't. Yeah. 1 liter of solution has 1.7 moles of NaCl. That is called molarity. Yes, that is called molarity. So I'll just ask you a random question. This is something that we'll keep applying quite a lot while solving questions. I have a solution that has molarity equal to 13, let's say. Ghati as a number le liya. I have a solution that has molarity equal to 13. Okay. I take 200 milliliter of this solution. What is the total number of moles of solute in this 200 milliliter solution? Can you tell me? I have a solution that has molarity equal to 13. Okay, so the solution can be written as a 13 molar solution. 13 bolo to 13. Capital M represents molarity. I take 200 ml of this solution. What's the total number of moles of solute in 200 milliliters? How will we do this? Let's write it down step by step. It's very simple, but let's write it down step by step. What does the statement mean? 13 molar implies that I have 13 moles of solute in 1 liter of solution. Can I write 1 liter ki jagah 1000 ml of solution? Yes. Now my dear friends, let's just divide by 1000 on both sides. If you want to do that, kar lo chalo, aise kar lo. Can I write 13 by 1000 moles in 1000 by 1000 milliliter of the solution? I can simply write this as 1 milliliter solution. Now multiply both sides into 200. By doing some basic mathematics, you could have simply divided 13 by 5. Yeah. So ultimately, how much do I have? Ultimately, I have 13 by 5 moles. Yeah. In 200 ml of solution. Isn't it? 2.6. 2.6 moles in 200 milliliters of the solution. That is all molarity is. There is nothing more to molarity. A lot of people get scared by molarity. No need to get scared. This is all it is. Okay, this is all it is. Okay. So do you realize that it is as good as just multiplying molarity into volume? Moles is equal to molarity into volume. Karna wahi hai, just make sure you take volume in liters. I could have simply written 13 into 0.2. I could have written that as well. Yeah. I could have written that as well. 0.2 liters. That's what 200 milliliters are. Okay. So number of moles is equal to molarity into volume. Just remember this. Okay. Please never forget this idea. Number of moles in a solution of solute is equal to molarity into volume. Khatam. Nothing complicated about it. Cool. So before getting into molality, let's just revise all of these. Mole fraction, fraction of number of moles. Mass percent, percentage of weight of a certain component. Mass by volume percent, grams of solute present in 100 milliliters of solution. Volume by volume percent, percentage of volume of the solute. Grams per liter, pretty obvious. Parts per million or parts per billion, amount of solute in 10 to the power 6 or 10 to the power 9 parts of the entire solution. Molarity, simply moles of अच्छा ये molality पहले दिया है यहाँ पे. हाँ, molarity is simply moles of solute divided by liters of solution. Now molality is different. Okay, molality over here is the odd one out. Molality is the odd one out. Let me tell you why. Just pay a little bit of attention, okay? Look at the definition of molality. Very beautiful, simple definition. It says that it represents the moles of solute present in 1 kilogram of solvent. Did you notice the difference? I have made it pretty obvious, I am sure. Did you notice that we are talking about the solvent over here, not the solution? We are talking about the weight of the solvent over here instead of talking about the volume of the solution. Makes sense? represents the moles of solute present in 1 kilograms of solvent. It's as good as saying I have dissolved 2 moles of NaCl in 1 kilogram of water. Okay, kilogram of water. So if I ever write a statement like this, 2.5 molal, okay, MOLAL बोला जाता है. Okay, example 2.5 molal aqueous solution of glucose. It sounds like molarity को र बोलना नहीं आ रहा, तोतला हो गया molarity, molality, but it's a different word altogether. Yeah. 2.5 molar aqueous solution of glucose. What does this imply? It implies that there are 2.5 moles of glucose present in 1 kilograms of water. Present in 1 kilograms of water. Now you must be wondering, sir, why did we come up with molality when molarity was giving us enough ideas? Yeah. The good thing about taking moles and weight is that this particular standard is temperature independent. Do you realize what I mean when I say temperature independent? This does not depend on temperature. Does weight change with temperature? No. If weight changed with temperature, then it would become light or heavy depending on the season. Yeah. So weight doesn't depend on temperature, but volume depends on temperature. Volume can expand or contract with temperature. Yes. So things like molarity, these are temperature dependent. Yeah. So let us say you are working in a chemical laboratory in India and you want to order a specific solution that is available only in Russia, and you know Russia is very cold, India is hot. So what will happen? You order a solution from Russia and you're like, let's say Amar is ordering the solution. So we'll be like, hey bro Amar, I'm sending you 2 molar solution from Russia. I don't know how good that Russian accent was, but yeah, imagine. I'm sending you 2 molar solution from Russia. Regards. My name is Vladimir. Great. So Vladimir sends you 2 molar solution from Russia. But by the time it reaches India, do you realize India is hot? The volume is most likely going to expand. Instead of being 2 molar, do you realize the molarity will decrease? Because the volume has increased. If it was 2 moles in 1 liter, by coming to India, that solution has become 1.5 liters, let's say. I'm exaggerating, of course, but the volume will increase. So Amar will call Vladimir back and Amar will be like, bro, you sent me wrong solution. It is not 2 molar. It is 1.7 molar or something. Yeah. So that is why molarity fails whenever you're transporting solutions from one place to the other. So it's better that Vladimir simply had said, Amar bro, I'm sending you 2 molar solution. Regards, Russia. So molality is better. Amar will receive it and Vladimir and Amar will be happily ever after. Whatever. The point. Do you understand the point? Molarity depends on temperature. Molality, on the other hand, does not depend on temperature. Hence, it makes good sense to use this as well whenever temperature is a concern. Yeah, and you would learn in the chapter of solutions in 12th class that you take molality all over the place whenever you're talking about elevation of boiling point, depression of freezing point, etc. These ideas are something that you will study in colligative properties in 12th class. You would realize that we talk only in terms of molality over there. Okay? Cool. So people, the fun thing is that we now know all of these ideas. And can we write one by one which of these are temperature dependent and which of these are temperature independent? Mole fraction, number of moles doesn't change with temperature. Temperature independent. Yeah. Mass percentage, mass doesn't vary with temperature. Temperature independent. Weight by volume, volume changes with temperature. Temperature dependent. Volume by volume, volume of the solute can vary differently, volume of solution can vary differently. So this is also temperature dependent. Grams per liter, temperature dependent. Parts per million, parts per billion, depends. If you are taking it in terms of volumes, yeah, 250 ml rice in 250 into 10 to the power 6 ml of solution, then it depends on the temperature. If you're talking about parts per million in just mass, then it doesn't depend. Yeah? So parts per million and parts per billion depends how you express them. Molality is temperature independent, and finally your molarity is temperature dependent. Wherever you have volume, it's temperature dependent. If it is not, temperature independent. Very simple idea. If you were confused ever in this earlier, don't be confused anymore. ठीक है जी, चमक गया, बहुत सिंपल बात है, मज़ा आ गया. Great. So people, before I get into some questions right now, let me give you this piece of information. Questions related to these concentrations will be discussed on Thursday at 7 p.m. Okay, कौन सा Thursday है ये? If someone is watching this in the year 2050, hello. But yeah, I'm talking about the Thursday that is 11th of June 2020. Okay. Cool. That is when we will discuss the questions related to these concentrations. But for now, let's look at some different questions which are pending from the previous classes. Okay. So, people, glad to see you here attending this class, hundreds of you. And if you enjoyed the explanation of solutions, then make sure you hit that like button. Makes me a little happier. Now, this is something that was the homework from the previous class. Let's just solve it quickly. Stoichiometry का सवाल था. So KClO4 may be made by the means of the following series of reactions. How much Cl2 is required to prepare 200 grams of KClO4 by the above sequence? So essentially you had to figure out the ratio in which Cl2 and KClO4 are related. Yeah. There are two ways of doing this question. One way of doing this question is by starting from Cl2 and going to the bottom. Yeah, that one Cl2 can give this much, so on, so on, so on. The best way to solve this question is by looking at KClO4. You are getting 3 moles of KClO4 at the end, starting from 4 moles of KClO3, right? From where is this KClO3 coming? This KClO3 is coming from reaction number 2. All of the KClO3 in the last reaction is coming from this reaction, and we need 4 moles of KClO3 at the end. Can I just multiply this reaction with 4 to get 4 moles of KClO3? Let me do that quickly. So I can write 4 KClO3. यहाँ पे आ जाएगा 4 into 2 times KCl और यहाँ पे आ जाएगा 4 into 3 KClO. So 4 moles of KClO3, which are required to create 3 moles of KClO4, are created by 3 into 4, that is equal to 12 moles of KClO. Bottom to top makes our life simpler, right? So from where am I getting 12 moles of KClO? I am getting these 12 moles of KClO from the very first reaction. So in order to get 12 moles of KClO over here, let me multiply the entire first reaction with the number 12. How can I do that? I can write that by just writing 12 all over the place. 12 into 2 KOH hardly matters to us, and 12 Cl2. Now the numbers that we've written make a lot of sense. Read them carefully. Okay. 12 moles of Cl2 will give rise to 12 moles of KClO, which when used will give rise to 4 moles of KClO3, which when used will give rise to 3 moles of KClO4. So I can write over here that 12 moles of Cl2 give me 3 moles KClO4. Now we have the ratio. So I can write over here that 4 moles of Cl2 give me 1 mole of KClO4, isn't it? So now all you need to do in this question is to calculate how many moles of KClO4 are these, multiply that with 4 and convert that into the weight of chlorine. When you do that, the answer that you will get will be equal to 410 grams. Very simple. This is the ratio that is required. Now, conversion of moles into weight and weight into moles, we've been doing that for the last 2 classes. In case you've missed the first 2 classes of this epic mole series, please make sure you watch that. The playlist is in the description down below. But yeah, very simple question, isn't it? Okay. The only thing is you needed to go from bottom to top to figure out the ratio of chlorine versus KClO4. If you're doing this question for the very first time, it's a good question. If you've done this question earlier, then well, why are you here? ठीक है जी, हो गया. So this is how it works. This is the ratio that we needed. For the people who gave me the correct answer, we'll see their names in some time. I'll show you the names as well. Let's just do 2 more questions before I show you the names of people who gave me the correct answer in the previous classes. Comments. ये करते हैं. Calculate the amount of lime, CaO, that can be prepared by heating 200 kilograms of limestone that is only 95% pure. Can we do that very quickly? चलो करके देखते हैं. So people, CaCO3 converts into CaO plus CO2. This is a reaction that you've studied in earlier classes as well, in 9th and 10th, right? Now what is given is that CaCO3 is 200 kilograms, but this is only 95% pure. This is only 95% pure. So out of 200 grams, how much is actual CaCO3? Actual CaCO3 is only equal to 95% of 200 kilograms. That is equal to how much? कितना आ गया ये? 190 किलोग्राम. Yeah. This is 190 kilograms. Now, do you remember the molecular weight of CaCO3? Calcium carbonate's molecular weight, does anyone remember? I think it is 100. Uttam is enjoying the class. Uttam, thank you so much, man. I think the weight of CaCO3 is 100, isn't it? If I'm not wrong. If I'm wrong, then please correct me. Yeah. So what it implies is, okay, moles of CaCO3 over here are equal to 190 divided by 100, that is equal to 1.9 kilomoles, because this is kilograms, है ना जी? किलोग्राम तो किलोमोल आएगा ना यार. This is moles into 10 to the power 3, not just 1.9 moles. This is 1.9 kilomoles because this weight is in kilograms. Kilograms upon grams per mole will give you kilomoles. Okay, so 1.9 kilomoles. So out of 1.9 kilomoles of CaCO3, you will get 1.9 kilomoles of CaO. Yeah, this will gives me 1.9 kilomole of CaO. That's it. That's the answer. You can calculate the weight of this if you want. You can just multiply this into the molecular weight of CaO. You will get the answer in kilograms. 106 kilograms, I guess. Yeah. Cool. So the answer, if you convert this into moles, if you convert these moles into mass, you will get somewhere around 106 kilograms of CaO. ठीक है. Very simple idea. So whenever this percentage purity is given, just take care of that. Okay. Now next question, and after this question I will show you the people who answered the question of the homework correctly. ये देखो. The example says the molar mass of A is 128 grams per mole, X is 148 grams per mole, and on controlled oxidation, X gives, okay, A on controlled oxidation gives X according to the following reaction. 2A plus 9B gives 2X plus 4Y plus 5Z. Okay. Some of the reactant A oxidizes and only 70% of the maximum yield is obtained. Do you understand the meaning of the word yield? ये percentage yield समझते हो? I'll give you my typical example. Let us say that Om, okay, let us say that Om Kumar in the chat box has an apple farm. Okay, apple orchard है मान लो Om का. So Om plants a lot of apples in the season, and at harvest he's expecting, okay, at the harvest Om expects let's say 1000 kilograms of apples. Okay, very big orchard. He expects that 1000 kilograms of apples will be produced. But after harvesting, you realize that a lot of insects were there. Yeah, a lot of problems happened. Hailstorm happened. Things of different sort happened. Yeah. Ultimately, after the harvest, you realize that you get, okay, Om harvests 100 kilograms of apples. Expected 1000, but because of the season, etc., 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 you got only 100 kilograms. So, my dear friends, can you tell me what's the percentage yield of apples over here? Percentage yield over here is equal to, isn't it? Out of the expected 1000 kilograms, only 100 kilograms were obtained. This is how much? 10%? Yes. Aftab, welcome, man. Box of Trends, thank you. Yeah, people in the chat box, I sometimes look at the chat box, so I hope if I was not able to answer your query directly, sorry. Simran Punjabi bhi bol lange, koi chakkar nahi. Yeah, people, so this is what's going on. The yield is very less, 10% yield. This is what yield means. Okay, this was a very random example over here. Om was saying that I'm ignoring him in the chat box, so I gave him some apples. All right, so can you do this question now? Sum of reactant A oxidizes and only 70% of the maximum yield is obtained. Okay, so you were expecting A to give X. Okay, so expected क्या था? Expected was, क्या spelling लिखे मैंने यहाँ पे? The expected idea was that 1 mole of A gives me 1 mole of X. Do you realize their stoichiometric coefficients are the same? 2:2, 1:1, yeah. This was expected. But actually what happens is 1 mole of A gives rise to only 70%, that is 0.7 mole of X. This is the ratio. Now can you do the rest of the calculations? So my dear friends, the rest of the calculations for you now have turned into a homework. So like every class, what we do is we have a homework. This is a homework for you for the next class. So this is something that you have to answer in the comment section of this video. Okay, बाद में comments में answer देना इसका. Okay, answer in the comments, not the chat box, answer in the comments. And also tell me what is your favorite, what's your favorite pastime? Okay, what's your favorite pastime? Like what do you do when you just want to chill? Yeah, for example, I love to sleep. I either sleep or I cook food, or the best thing that I love is to go on a bike ride. Yeah, so that's my favorite pastime. Whatever is your favorite pastime, just tell me whether you want to like to read books, whether you like to play music, whether you listen to music, etc. So answer this in the comments. Tell me your favorite pastime in the comment section as well. Now people, one tiny piece of information for you before I show you the names of people who've given this answer correctly in the previous class. The information for you is that we have brought micro courses for you. Essentially, if you want to study with us on Vedantu, and let's say you want to test how Vedantu's patented platform is, you want to see how teaching works, etc. You don't want to spend a lot of money. So what you can do is just go to the comment section down below. The first comment that is there, the pinned comment, okay? In that comment section, there is the detail for micro courses. So those are like 1 rupee courses. 1 rupee is just a formality once again. Okay? 1 rupee courses so that you can experience what the Vedantu patented platform looks like, what all paid courses look like. So in case you want to see that, you can, in the comment section down below, you can enroll in the micro courses. And micro courses are good for, you know, learning the entire chapter. If you don't want to spend a lot of money for full term courses, so you can spend money on just 1 chapter, learn it, just rupee 1. You get the idea. Enough. Chalo ji. So now I will show you the comments that we got in the previous video. Yeah. Let me make myself small. I'll put myself here on the side of the screen. So what I've done is I have opened the previous video of stoichiometry. I have sorted the comments by newest first. Okay. न्यूएस्ट फर्स्ट पे कर दिया. सो द ओल्डेस्ट कमेंट्स आर द फास्टेस्ट कमेंट्स. लेट्स सी. There were 91 comments on the video. Very nice. We'll just read the first few names who've given the correct answer. Let's try to load it up. And I'm showing you the comments directly because sometimes people say, sir, I commented but you didn't say my name. So I'm just showing the comments directly. Yeah. Someone says preview is better than live class. We'll do both of them. Chalo ji. So, acha. Vaneet Garg says 4. Vaneet, what? अच्छा, lots of people giving compliments etc etc etc. आंसर कहाँ चलेगा भैया? हाँ, यहाँ से आंसर शुरू हो रहे हैं. सो नीलिमा said 410 grams of chlorine. Absolutely correct. Great innovative learners. Thank you so much. Pratham, wrong answer bro. Please try to solve it again. I've given you the hints in today's class. Ayush, very nice. Good job. Ayush loves cauliflower. Simran, 410 gram, absolutely correct. 4, yes, you've correctly calculated the ratio. Lady finger, yes, even I like that. Okra. Yeah, Ani, your answer is absolutely correct. You do not like vegetables. Interesting. अच्छा, iron वगैरह का भी आंसर दिया है Pravati. Okay, I think your answer is correct. Daljit is saying that Daljit likes Karela and Bhindi. 410, absolutely correct. Soham, absolutely correct. Ruchi, very nice. Shyam, good man. Pravati, very nice. DD Matix, Shivanshu, Satish, Asmita, and Mayank, Rafia, Krish, Akhil, Aman. Okay, very nice. So I have taken the names of lots of people over here. Very good job. If I wasn't able to take your name, I'm very sorry because there were almost 100 comments on the video. But I hope you understand that accuracy is what matters. Your name doesn't really, I'm not giving you any admission in any college. So if you got your name in the video, okay, good, high five. Even if you didn't, even if you calculated the answer correctly, that's all that matters. So great job, people. Thank you so much for attending today's class. That's it from my side. I will take your leave. In case there are any more comments or queries that are remaining, you can leave them in the comment section along with the answer to today's homework question. And apart from that, thank you so much for joining in. Make sure you hit that like button if you enjoyed the intro part of the video. And I will see you once again on Thursday at 7 p.m. So until then, bye bye, take care. See you soon.